Lesson 1-6, Solving Problems Involving Rates of Change. In this video, the second video of this lesson, we're going to find the equation of a tangent line that passes through a function. So let's remind ourselves what a tangent line is. When you have a function that looks like this, right? The tangent line passes through that function, and the slope of this line is the instantaneous rate of change at that point. Right? So if we are given a function and we're given a point, we can find the equation of the tangent line that passes through that point to that function. Let's see what I mean here. Find the equation of the tangent line to f of x equals x cubed minus 3x at x equals 1. So if we know, so how do we form an equation? Let's talk about that. This is a line, right? So we are looking to fill the template y equals mx plus b, right? That's what we are hoping to do here. And so we need to find m, we need to find b, right? M is your slope, b is your y-intercept. So which one of these can we find? Well, we can find the slope because it's just the instantaneous rate of change at that x value, right? So we are going to find the instantaneous rate of change at x equals 1. So we are doing f at 1.001 minus f at 1 all over 0.001, sorry. Here, it actually makes sense to call this thing m, right? Because that's what our m value is going to be, so we might as well call it m. And so now we have two tasks to do. Find f at 1.001 and find f at 1, all right? So these will need your calculator, so you're going to want to get your calculator out here and do 1.001 cubed minus 3 times 1.001. And when you do that, you should get 1.001 cubed minus 3 times 1.001. Should get negative 1.9999. How many nines do I have there? 5 nines? 6999. I'm using an iPhone calculator right now, so this might be a little bit more than your phone calculator gives you. It's all good. Just try to keep all the decimal places you're given. And f at 1 would be 1 cubed minus 3 times 1, which is just negative 2. Again, we're anticipating these two should be very close, right, from our work on rates of change. All right, and now let's plug this back in to find m. So we have negative 1.99996999 minus 2 all over 0.001. All right. So we have, when we do this calculation, we have negative 1.99996999 minus 2. Sorry, minus negative 2. I should have written that like that, sorry. Minus negative 2. And that ends up being very close to 0, even after we divide it by 1. We get 0.003001. All right, so what does this mean? Well, this means the slope is most likely very close to 0. So how do we do it from there, right? We know m is 0, so what next? We have the equation right now, y equals 0x plus b. Okay, well, that doesn't make much sense right now. We know that 0x is just 0, right? So this is pretty much just y equals b. And then what do we do from there? Well, we still need to solve for the b value. So we need a point to sub in here. So we need to find a point on this line. And what point do we have on this line? Well, we have this. We know that f at 1 is negative 2. So I'm going to substitute that in, and I'll substitute it into the original equation here. Negative 2 is 0 times 1 plus b. Well, 0 times 1 is 0, so negative 2 is b. Okay. The reason why I'm walking it through like this is because you might get a situation where m is something else. You might get m is 3. In which case you would have to follow these steps through to solve for b. Okay, so watch out for that. But otherwise, we have that negative 2 is b, so we can form the equation 0x minus 2, or just -2. Let's remind ourselves what we're doing here. And to do that, I'm actually going to bring up Desmos here, just to kind of show us what we're doing. So here's our equation, x cubed minus 3x. This is a cubic function, looks a little bit like that. And here's our point, 1, -2. We want the tangent line through that point, and so the slope of the tangent line is the IROC. However, the IROC is 0, so we just want a 0 slope going through that point, and that point is y equals -2. So you can see that it is doing what the function is doing. It only crosses through that section at that point, okay? And here you go. So that is the process for finding tangent lines. Maybe I should write out the steps a little bit better. We're finding the IROC at x equals -1, right? This is the m value. And you're going to plug in m. This is step 2. Plug in m as well as the xy point to solve for b. And then finally, state equation. All right, so a little bit disjointed there, but these are your steps. This was an interesting scenario just because m was 0. That might not always happen though. So these are the steps you do want to follow. All right, so that's there for you. Come back to this video if you ever need a refresher on how to do a question like this.